concept that is commonly tested within AP Physics, and it is the difference between distance and displacement. So you may ask yourself, what exactly is the difference? Well, distance is simply defined as the total distance that something travels, including all the curves, paths, all the various different idiosyncrasies that typify a common physical path, while displacement simply typifies the distance traveled between 2 points, the start and the finish. A good example of this is a simple illustration, where one may start at point A and end up at point B. The distance directly between these 2 points, no matter the path that you take, is known as the displacement, and that is delta x. The distance, however, is typified as the actual path that you take and how far you move during that path. So essentially, you may move something like this, and then you might turn around, and then you might head all the way back, and then you might come back, and then you finally end up at B. And the distance s of this path is your distance. Measuring a distance, that is non-linear, can only be accomplished by algebra. And since this video is going to be algebra-based, we are not going to touch non-linear distance at this moment. In a future video, probably the next video, we will cover calculus-based kinematics, and there we will discuss the measurement of distance. However, displacement, since it is always simply a linear straight line, or vector in this case, we are capable of measuring that with classical mechanics and algebra, essentially. Basic mathematics. So, to begin, we are going to start with an example, which is based on a Cartesian plane, and we are going to be moving from point A to point B. So, here we have point A, our starting point, and we are moving to point B. So you may ask yourself, what is the displacement? This isn't really helping, you're just drawing arrows. Well, let's calculate some stuff. Essentially, the distance, or the displacement in this case, the actual measurement of displacement can be found by taking what is known as the magnitude of a vector. So if we call this x, and we add the vector symbol on top, taking the magnitude of x will allow us to find the actual value of displacement. So essentially, in order to measure that, you take the magnitude of x with 2 bars on either side, that means magnitude, and you simply take y2 minus it's y2, not exponent 2, minus y1 plus x2 minus x1. And you simply take the square root of that value. However, a vector must also be typified by direction. The direction we will get to in a moment. However, for now, let's simply calculate the distance, or the displacement, my apologies, of this vector. So, in order to calculate the actual magnitude of this vector, we simply take double bar magnitude of vector x is equal to the square root of, since we're ending at point B, y2 is obviously going to be 0. So we're just going to say 0 minus y1, which is 5. Oh, I forgot. You have to square both of those values. My mistake. 0 minus 5 squared plus, of course, x2 minus x1 squared. So x2, negative 2, minus 5, negative 7. So using simple mathematics, we just found that that would be negative 7 anyways. So that means that the magnitude of x is going to be equal to the square root of negative 5 squared, which is 25, plus negative 7 squared, which is 49. So if you simply add these values, you have the square root of 74. That is the magnitude of this vector. So no matter which way, no matter how you've traveled from here to there, whether it's something in this manner, where you're just constantly moving and then you finally end up where you were again, your displacement overall during your journey is going to be the square root of 74. That is the actual value. However, if you wish to calculate the angle at which you have left, what direction should I go? Well, for that, you simply need to utilize basic trigonometry. And for that, you would simply calculate the components. These are known as the components of your vector. Every vector has two components. Its x component, just down here. So you have v of x, assuming that this is v, and v of y. Every vector is composed of two vectors, assuming that it's in two-dimensional space. However, we are not going to cover three-dimensional vectors at this moment. It's a little early for that. However, in order to do this, simply calculate your component vectors, and you would find that, of course, since your initial y value is 0 and this is 5, this is going to have a height of 5. So Vy is equal to negative 5, since we are moving down 5. So we're going 1, 2, 3, 4, 5. We're just going down 5. Now, moving on, since we have negative 2 and 5, that means that our total distance this way is going to be 7. So we're going to move back 5, and then we're going to move back 2 more. So Vx is equal to negative 7. Alright, so now that we have found those values, we can find the actual angle at which we left, which is known as theta. So, in order to calculate theta, we simply need to utilize our basic inverse trigonometric functions. So, since we have our opposite value, our opposite value and our adjacent value to theta, we simply want to find x. This would actually just be xx and xy. I initially utilized v because it would be kind of confusing, but now I realize that it would actually be more confusing otherwise. But, moving on. So in order to calculate the angle at which we actually moved from there, we could say that we have tangent inverse, because remember, tangent relies on what? It relies on the adjacent and the opposite. Tangent inverse of negative 5 opposite over adjacent. If you're confused by this process, chances are you have a somewhat weak grasp upon trigonometric functions, and for that I would recommend that you check other resources concerning mathematics itself before you delve into this. But moving on, this simply simplifies to tangent inverse of 5 over 7, and if you calculate that, that should now if you calculate the tangent inverse of 5 over 7, you're going to get 0.62 radians, and in degrees, that is simply 35.53. Now that we have found the direction, we now have an actual vector. The definition of a vector is a given distance or value that both has magnitude and direction, and that is what typifies an average vector. Also, although I said that you usually need calculus to calculate distances, you can also utilize basic algebra, or geometry for that matter, to calculate basic distances of nonlinear paths. So below we have what's known as a VT graph, a velocity time graph, and over time, as you can see, our velocity has increased, and it's moved on, and then it's decreased, and then we start having negative velocity, which means that we're actually accelerating backwards, since it's increasing in this case. And then we start decelerating in the opposite direction, and then we stop. However, if you wanted to calculate the total distance that you've moved, you would simply add the area under the graph, which we call in calculus an integral. You would simply add the area under the graph on the top to the area under the graph on the bottom, the absolute value of this. This part right here, if you were to subtract this from this, you would have displacement. You would not have distance. So in order to calculate distance, you simply add the absolute value of both of these areas. As a final summary, I wanted to say that distance, you could say that it is actually congruent to scalars, since it doesn't necessarily utilize direction. And also, displacement is always a vector. Never forget that displacement is a vector, and it is always represented by delta x. That is displacement. So I hope this video helped. This was simply just an overview of the discrepancy between distance and displacement. Thank you for watching. No bye.